In this video, we will solve problem number 26 in chapter 1. So in this problem, we need to find a tensor T that has the following eigenvalues: mu1 equal to 1 and mu2, mu3 equal to 3. Also, we are given two eigenvectors for this tensor, n1 and n2. So in the first part of the problem, we will try to find the tensor T in E basis, and in the second part of the problem we will try to show that the eigenvectors for this tensor that has repeated eigenvalues are not unique. So to start with the first part, which is finding T in E basis, obviously we need to find N3, and we can easily find N3 by the cross product between N1 and N2, and by doing so we get our third eigenvalue or eigenvector. So now we have all the eigenvectors in N basis. So by the spectral decomposition we can get our T in N basis. So in this problem we need to find T in E basis. So obviously we need to find the transformation matrix, which is Q, and we can find Q by the dot product between the N basis and E basis, and by doing so we get our transformation matrix Q. Now we plug in back into the matrix multiplication formula, which is T in E basis equal to Q transpose T in N basis into Q. So by doing the matrix multiplication, we get our T in E basis. So now we are done with the first part of the problem. We already found T in E basis. Now we want to show that the eigenvectors for this tensor that has repeated eigenvalues are not unique. So to start with, we need to choose the first eigenvector. So we will choose the same n1 in the first part. Then we will try to choose two different eigenvectors, n2 and n3. We will call them this time n2 prime and n3 prime, that are orthogonal to n1 and they are unit vectors. So to find n2 prime, obviously we need to use the projection matrix that projects any vector on a plane that has n1 as a normal to it. And the reason we are using n1 here is because we already have n1, so we will start with the plane that has n1 normal to it. So we will choose that vector to be e2. So if we do the matrix multiplication here, we will get our n2 prime, and obviously we need to normalize this vector to get a unit leg vector. So we will get our n2 prime. So then we need to find n3 prime. Since we already have n1 and n2 prime, we can do the cross product and we will get our n3 prime. Again, now we need to find the transformation matrix. Now we will call it Q prime, which is the dot product between n prime and the E basis. By doing so, we will get our Q prime. Now we're plugging back into the matrix multiplication formula. Now it becomes T in E basis equal to Q prime transpose T in N basis Q prime. By doing the matrix multiplication, we get our T in E basis. And this is going to be our new T in E basis. And if we can compare this TE with the one that we got in the first part, we see they are exactly the same. So by choosing two different eigenvectors, n2 and n3, that are orthogonal to n1 and they are unit vectors, we got the same tensor T in E basis. So the conclusion here is eigenvectors for repeated eigenvalues are not unique.